Hello everyone, welcome to my chemistry channel, BL the Short and Sweet in Chemistry. Now I am going to explain the topic reaction mechanism, that is for class 11th. Now the reaction mechanism, that topic is very important for class 11th and class 12th. But now I am going to explain, that is part 2. Already in part 1 I have explained how the methane react with chlorine in presence of sunlight. Now in part 2 I am going to explain addition reaction. I think you know what is the addition reaction. When you read alkene, at the time you can see what is addition reaction. That means between double bond the reaction takes place. Without double and triple bond the reaction will not occur. So here addition reaction of alkene with HBr. Very important here, HBr, HCl and HI all will react, but very important, the hydrogen bromide or HBr is very important, which react with different type of alkene to form alkyl halides. Here you can see there are two types of alkenes. One is symmetrical alkene. One is what? Symmetrical alkene. And this symmetrical alkene, what is meant by symmetrical? Other one is unsymmetrical alkene. Now what is meant by symmetrical alkene? You can say when there is a double bond, between double bond both sides have carbon and hydrogen. Now you count the number of carbon, number of hydrogen on both sides of the double bond. Because I am going to explain about alkene, so between double bond you see how many number of carbon, how many number of hydrogen present. If the number of carbon and number of hydrogen are same on both sides of the double bond, then it is called symmetrical alkene. Now you can see this is the example where we can see that is what is meant by symmetrical alkene. The symmetrical alkene, that here CH2 double bond CH2. Count here carbon. Right side 1 carbon, 2 hydrogen, left side also 1 carbon, 2 hydrogen. What is the name of CH2 double bond CH2? That is called ethene. Now similarly you can see other that mean double bond, that is symmetrical alkene, that is but-2-wine. What is but-2-wine? But-2-wine mean here you can say that is wine, sorry, it is not wine, in. So it is in because it is a double bond. Since a double bond, that is called alkene. And since this one here double bond alkene, and how many carbon? The carbon is 4 carbon. And now you count carbon and hydrogen on both sides. On both sides you count. Left side 2 carbon, 5 hydrogen. Similarly right side also you can observe 2 carbon, 5 hydrogen. And now this is called but-2-in because suppose it is 1 and it is 2 and it is 3 and it is 4. That means here after 2 there is a double bond, that is why but-2-in. Then come to what is unsymmetrical alkene. If number of carbon and hydrogen atoms are not same on both sides of the double bond, you see the double bond, on left side you count carbon, hydrogen, and right side also you count carbon and hydrogen. See here in propene, 2 carbon, 4 hydrogen, and right side 1 carbon, 2 hydrogen. What is the name? Propene. And the name is propene. Now this propene, what you see, this propene having form structure CH3, CH double bond CH2, propene. Now similarly but-1-wine. What is but-1-wine? See, this is the 1, this is the 1, this is the 2, and this is 3, and this is 4. And after 1 there is a double bond, that is why it is called but-2-wine. Have you clear? But-2-wine, and here it is sorry, it is not wine. Again I have mistake here, mistakenly it is written, and that is actually it is but-2-in. Sorry, it is but-2-in, and that is also And here you can say but 1 in. Why it is but 1 in? Because it is the after 1 there is a double bond. And you see here after 2 there is a double bond. This is symmetrical. But here it is called unsymmetrical because the number of carbon, hydrogen on both sides are not same. So it is propene and this is butane, but 1 in, it is but 2 in. Sorry, it is not Y, it should be E. Now here you can say that the two type of alkene are there. One is symmetrical, other one is unsymmetrical. Next you will see how the reaction takes place. That means, suppose we know very well when ethene reacts with HBr, here it gives what is the product? CH3, CH2, Br. What is the main? 2 carbon there and 2 carbon, that is CH3, CH2, Br, ethyl chloride, or you can say, sorry, it is not chloride, it is ethyl bromide. So here also it is written as ethyl chloride, but it is not ethyl chloride, ethyl bromide. Then what happened here? You can say it is ethyl bromide, or you can say bromoethane. Then how? How it is 1 bromoethane? Now when HBr is added, if you add right side Br and left side H, the meaning is same. And similarly, if you can say left side 1 Br attached and right side 1 hydrogen attached, then the product is same. That means there is no difference if you add hydrogen on left or right side. Left side there is no difference. The product is always CH3, CH2, Br. Whether the Br comes to right side or Br comes to left side. Because it is symmetrical alkene. For symmetrical alkene, there is no problem existing. But if a unsymmetrical alkene, I told what is unsymmetrical alkene? That means the double bond, between double bond, what are the carbon, hydrogen present, they are not same on both sides of the double bond. Then come to, it followed for symmetrical alkene, the main rule, that is the Markovnikov rule, is followed. Then what is Markovnikov's rule? Markovnikov's rule is very important for the addition reaction of alkene and alkyne. Here it says negative part of the addendum. Addendum means here adding molecule. What is you are adding? HBr. This is called addendum and it is addition molecule because here H is added, Br is added, and Br is the negative part and H is the positive part. So addendum here, what is adding molecule? What is the adding molecule? Having negative and positive part. And now what is the rule? Negative part of the adding molecule, you see, that will go to hydrogen, here this hydrogen, sorry, that will go to the carbon, this carbon, having less number of hydrogen. Again see, what is the rule? Negative part of the adding molecule will go to the carbon having less number of hydrogen atom. Now here it is less number of hydrogen atom. That is why you can see the product. The Br will come to this carbon. That means 1, 2, 2 carbon, 2 position. 2 position carbon, the bromide or bromine will go to the carbon. Then what is the name of the product? 2-bromopropane. Again see, I am going to explain again. And here ethene is reacted with hydrogen bromide. It will give CH3, CH2, Br. Why? Because it is a symmetrical alkene. Whether Br come to first carbon or second carbon, there is no difference of that. Getting the same product, ethyl bromide. But for unsymmetrical alkene, Markovnikov's rule followed. What is that Markovnikov's rule? The negative part of the adding molecule attached to the carbon which has lesser number of hydrogen atom. So now see propene. Propene means here you can say the Br will come to the 2 number because the less number of hydrogen are there in this carbon. This is number 1, 2, 3. So name is 2-bromopropane. Then come to what is the mechanism then? The mechanism of addition of HBr to propene. Because propane is a unsymmetrical alkene, and here it will follow the Markovnikov's rule. And here HBr is added. Then what happens here? Step 1, HBr, that is ionizes. What is mean ionizes here? And here it is a covalent bond having 2 electrons. And what happens in 2 electrons, and when it is undergoing that ionization, or you can say heterolysis, here you can see, and that pair of electron which forms covalent bond, it comes to bromide. It comes to bromide. And here it comes to bromide, and bromide ion having 1 pair of electron, and this is having positive charge. Then why this is happening? Bromine is highly electronegative when compared to hydrogen. That is why the electron pair which forms covalent bond, that comes towards Br. So it is having negative charge, having 1 pair of electron. And since deficiency of electron, so H plus act as a electrophile. So what happened? H plus act as a electrophile. In step 2, the proton, that is electrophile H plus, will attack to where? The question here, where it will attack? You know, Markovnikov's rule said it will attack to the carbon having less number of hydrogen. Now how many carbons are there? 1, 2, 3. This is position 1, this 2, 3. And the 2 carbon, that is having 1 hydrogen, which is less hydrogen in compared to other. That means this is 2 hydrogen, this is 3 hydrogen, in 1 position 2 hydrogen, in 3 position 3 hydrogen, in 2 position only 1 hydrogen, and here it will attack where it will attack this side. Then how? Mechanism say how? Here you will see there are 2 possible reaction, so that you can say which is more stable. That depends on the carbonium ion or carbocation. And here it forms carbocation. One is less stable, other is more stable, and see how the reaction takes place. So here you will see there are 3 types of carbocation or carbonium ion, and one is primary carbocation or carbonium ion, and next is secondary carbocation or secondary carbonium ion, and third is tertiary carbocation. But here only primary carbocation and secondary carbocations are available. Now what happens here when H plus, the proton, or you can say what is that? That means you can say this is electrophile. When attack, what happens? It gives one secondary carbocation. What is this? Secondary carbocation, because CH means secondary carbon and plus attached means secondary carbocation. This is one intermediate product, and also other one is here see CH3, CH2, then CH2 plus. That means CH2 means primary carbon, and plus attached, that means carbocation, or can say carbonium ion. Now see there are 2 carbocation possible, available and produced, and secondary carbocation and primary carbocation. So which is more stable? Just now I told secondary carbocation is more stable. It is more stable than the primary carbocation. Can you recognize which is primary carbocation and which is secondary carbocation? And now see, this is CS2, you know, this is primary, and plus sign is there in not in the carbon, so primary carbocation. And this is CH, that is secondary, and plus is there, so it is secondary carbocation. And so this secondary carbocation is more stable than this. And here you want to remember tertiary carbocation is more stable than secondary, and secondary carbocation is more stable than primary. In step 3, what happened? Which is more stable, that will react. So you will come to the step 3, what happens? In step 3, the stable carbonium ion, that is secondary carbonium ion, this one is the secondary carbocation, and the secondary carbocation is more stable, and that is why it will react with bromide ion having one pair of electron and gives the product, because CH is the secondary carbocation, the bromine will attach to CH, so it gives 2-bromopropane. Now this is the Markovnikov's rule, and this is the mechanism. After mechanism, you can say what is the product 2-bromopropane, what is the Markovnikov's rule say, that negative part will go to the carbon which contain less hydrogen atom, that is true by the mechanism. Then Antimarkovnikov's rule, where Markovnikov's rule is followed, at that time the scientist Kharas had come, and he proved that one effect is there, that is called peroxide effect, and gradually this is called also Kharas effect, because Kharas used that benzoyl peroxide. By the help of it, it will not follow Markovnikov's rule. That is why it is called Antimarkovnikov's rule. It is contrary to the Markovnikov's rule, and this happen only with HBr but not with HCl and HI. Then what is the meaning? Anti-Markovnikov's rule means it will not follow Markovnikov's rule. It is contrary to the Markovnikov's rule. And who told this one? Who discovered this one? Kharas scientist. So it is called Kharas effect. Here benzoyl peroxide is used. That is why it is called peroxide effect. And here remember, the only HBr is used in anti-Markovnikov's rule, but not with HCl or HI. That means you take unsymmetrical alkene, HBr only, and in presence of benzoyl peroxide. So this is the what happened with benzoyl peroxide. Then what is the formula of benzoyl peroxide? Benzoyl peroxide C6H5CO whole 2, and it is C6H5CO whole 2O. That means you can say what is the structure C6H5 C double bond O C double bond O C6H5. This is called benzoyl peroxide. Then what I told, this is applicable to also unsymmetrical alkene, but with the presence of benzoyl peroxide. And what is the reagent you will take? HBr, very important. HBr you will take, and benzoyl peroxide you will take. That is very important. And here what will product? What happen? It gives 1-bromopropane. When propene react with the HBr and benzoyl peroxide, it produces 1-bromopropane. But with Markovnikov's rule, it gives 2-bromopropane. This is the difference. So very important, benzoyl peroxide, and with benzoyl peroxide with HBr, the product. Now see, this is the propene, HBr, benzoyl peroxide, it gives 1-bromopropane. This is the product. Then what is the mechanism? Now it is called peroxide or Kharas effect, because after scientist Kharas, it is called Kharas effect, and since benzoyl peroxide is used, that is called peroxide effect. Then come to mechanism. And now you can see this is the long structure where homolysis takes place. What do you mean homolysis? It will divide in middle. That means homo means half division takes place. So it is called homolysis. And in homolysis, what is the result? It gives what are the type of radicals. Very important. This one you can see what happened. Now in first step, benzoyl peroxide undergoes homolysis. So what happened here? Here it will give 1 6 is 5COO, that is 2 times, and 2 6S5 having free radical, that is very important, and 2 carbon dioxide. That means that phenyl radical is very important, which will react with HBr. And here what happened? Again HBr, H will come to here, that is also homolysis, H here, and Br with free radical, that means free electron, that is called free radical, and Br dot, Br with electron is very important here, that is called bromide free radical. So what happened here? Bromide free radical. Now your reactant is propene. So propene you take plus Br radical having free electron, and which is very reactive. Immediately react with this, and also here also it gives 2 type of product, and both are having free radical. Remember, both are having free radical, but there are 2 types. One is primary, secondary here, but also tertiary is possible, but here only available, that is primary free radical and secondary free radical. Now here also one should remember, secondary free radical is more stable. This one is more stable than primary free radical. That means primary free radical is less stable, and more stable is secondary free radical. Here bromine is there, here also bromine at last. That means what happened after that? Now again see, with free radical it gives primary free radical carbon with the electron, and this carbon with electron here, secondary carbon here, primary carbon. Then here 2 types of radicals are there. One is secondary is more stable, and primary is less stable. Then come to secondary. I told secondary free radical is more stable than primary. That is why here this is the secondary one react with HBr, and here also homolysis takes place. Remember, homolysis takes place here. H will come to here. Okay, only H will come to here, and bromide free radical, because this reaction will continue and product more and more product form. That is why Br dot Br free radical is there. Now what is the product then? 1 bromopropane. So near about it is a major product because it is stable secondary free radical. Now here this is primary free radical, which is less stable. That is why it gives the minor product, that one 2-bromopropane. But in Markovnikov's rule, this is the main product, 2-bromopropane. But according to Antimarkovnikov's rule or peroxide effect or Kharas effect, this is the minor product. What is the name here? You can write this is the 2-bromopropane, which is very less amount, that is minor product, and 1-bromopropane is the major product. I hope it is clear. Again see, there are 2 type of symmetrical alkene and unsymmetrical alkene. For symmetrical alkene there is no problem at all, because both sides having same number of carbon, hydrogen. So with HBr there is no problem, same product is produced. But for unsymmetrical alkene, since the carbon atoms and hydrogen atoms are not same on the both side of double bond, that is why one rule, Markovnikov's rule, followed. According to Markovnikov's rule, the negative part of the adding molecule will go to the carbon having less number of hydrogen. That is why here 2-bromopropane from propene, this 2-bromopropane is the main product, and mechanism already explained. Similarly, anti-Markovnikov's rule, that is the against to Markovnikov's rule, or you can say contrary to the Markovnikov's rule, and since Kharas discovered this one, and that is what is called Kharas effect. And since here benzoyl peroxide is used, that is why it is also called peroxide effect. Now here also you can see secondary free radical is more stable, that is why 1-bromopropane is the major product and 2-bromopropane is the minor product. I hope it is clear to you. And please subscribe my channel BL Das Short and Sweet in Chemistry.